up, guys? Paper Pilot here, back with another video. Today we are gonna be starting A2 Mathematics, chapter number 1, Motion in a Straight Line. This is from mechanics, of course. So we're gonna solve a few of the past paper questions, and from there on, I'll lead you on how to do the questions. All right. So the first question is from 2020, variant 2. So a tram starts from rest and moves with uniform acceleration for 20 seconds. The tram then travels at a constant speed v meter per second for 170 seconds before being brought to rest with a uniform deceleration of magnitude twice that of the acceleration. The total distance traveled by the tram is 2.775 kilometers. The first part states that sketch a velocity time graph for the motion stating the total time for which the tram is moving. So we have to sketch a velocity time graph. So when we draw a velocity time graph, the y-axis is speed while the x-axis is time, right? So the y-axis over here is going to be speed. So velocity s minus 1 while the x-axis is time, right? Okay, so what does it first say? First part says that it starts from rest and moves with a uniform acceleration for 20 seconds. Right. Okay, so it starts from rest, so it starts from 0, it moves with uniform acceleration. Whenever it says uniform acceleration, that means constant acceleration. That means it's going to be a straight line upwards, right? So from here, 20 seconds upwards. Okay. Then it says the tram then travels at a constant speed for 170 seconds. Okay, so constant speed means a straight horizontal line, right? So over here, constant speed with same speed. Okay, then it says before being brought to rest with a uniform deceleration of magnitude twice that of the acceleration. Okay, so it then decelerates to rest, right? So from here it decelerates to rest. Okay. Now, first of all, we need to label it now. Okay. So, for 20 seconds, it accelerates for 20 seconds. So this is 20. Then it travels at constant speed for a further 170 seconds. So what is 120? What is 170 plus 20, which is 190? So at 190, until 190 over here, travels at constant speed. And this time we do not know, so we're just gonna write it as t. Okay, so if we consider this as acceleration a, this is gonna be minus twice a. Okay? It says minus because deceleration is negative. It's going downwards and upwards. That's why it's negative. 2a. So the total distance traveled by the train is 2.775 kilometers. So in a velocity time graph, how do we calculate the distance traveled? It's basically the area under the graph, right? So over here we can say it's a triangle here, a rectangle here, and a triangle here. So if you find the area of all three of these, we can equate that to this value, and we can find what else we need to find. Alright, so first sketching part is done. Now find v. So v is this constant speed over here. This part is v. Okay. So how can we find v? So there is one way we can find v. Alright. So first step that I would like to say is that from here to here it's 20 seconds. Acceleration is a. So what's the formula for acceleration? Acceleration is initial final minus initial. So final is v, initial is 0, and the time it takes for is 20. What about the deceleration? The deceleration, same as that, final speed, which is 0, minus initial, which we do not know, which is v again, divided by the time. Now here's the thing where we need to take notice, is that acceleration, right, constant acceleration is inversely proportional to the time taken. So what I'm trying to say is that over here, if it takes 20 seconds, right, from here, if it takes 20 seconds to accelerate, That means to decelerate, if the acceleration is doubled, that means the time taken to decelerate will actually be halved. So over here, if it takes 20 seconds, over here it's going to take 10 seconds. Hence, t here will be 200. Because over here it's going to take exactly 10 seconds to decelerate to rest, since the acceleration is double. So over here it's going to be 200 seconds. And it's going to be 10 seconds. Okay. So we can probably form a simultaneous equation. Right. Okay, so the first is a is equals to v by 20, and twice a is equals to minus v by 10. Right. But it says find v. Well, you know what? Instead of doing this, I think the better option is just using the area. So what's the total area? The area is first is the area of the rectangle, is half into base into height, which we're going to consider v. Then the rectangle, which over here is 170, so 170 into v, plus the triangle over here, so half into 10 into v. Alright, all of this is going to be equals to 2.775 kilometers. Nothing to take notice is that this is in kilometers. We have to convert this into meters. So we just have to multiply that by 1,000, which means 2775. Right. So now let's solve this. Half into 20, we get 10v plus 170v plus 5v equals to 2775. Right, so we get 185v equals to 277v. Divide that by 185, we get v equals to 15. Right, which is our answer. Okay, moving on to the next question. Find the magnitude of the acceleration. So over here we have to use the concept that we know. So the acceleration is gonna be 15 by 20, which is 0.75 seconds square. There we go, easy, right? Moving on to the question number 2. This is from variant 3, same year. A car accelerates from rest and moves in a straight line with constant acceleration a. Okay, for a distance of 50 meters. Okay, so the car then travels with constant velocity of 500 meters of a period of 25 seconds before decelerating to rest. Okay, the magnitude of this deceleration is this twice a. So sketch the velocity time graph. Okay, same as before. So let's do this. So the first part, it says that it starts from rest and moves in a straight line with constant acceleration a. Okay, so from here, constant acceleration for a distance of 50 meters. Okay, so for a distance of 50 meters, the car then travels at a constant velocity. So constant speed for 500 meters. Okay, before decelerating to rest. So it accelerates, constant acceleration, then stays at constant speed, and then decelerates. Constant deceleration. Okay, so we get a trapezium shape. So let's consider this as v, since we do not know what the constant velocity is. And let's consider this part. We don't know the time yet, but we do know that this period of time is 25 seconds. Right. And this is a, and this is minus twice a. Okay, so find the value of a. Alright, so we know the distance is traveled here. So there's two ways we can do this actually. Right. So we can use suvat. So what is suvat? Suvat is a list of formulas that you will have in your MF19. So first is S equals to UT plus half AT square. Then is V square equals to U square plus twice AS. Then we have V equals to U plus AT. Right, these two are the main formulas that we use. There's some other derivations for that, but we don't really need that. Over here, we know the distance it traveled, so we don't really need this. The third one, we don't really need that. We can use... Right, the second one. So the final velocity is v squared. Initial is 0, so you don't need to write that. Twice into acceleration a into s. Now s is the distance, which is 50. Right? So v squared equals to 100 times acceleration. Okay. Now it says that the car then travels at constant velocity 500 meters for a period of 25 seconds. So we can use that as well. Constant velocity. So speed equals to distance. Distance is going to be 500 by time, which is 25. So speed over here is going to be 20. So now we know the final velocity, which is 20. So 20 squared is equals to 108, which is 400 equals to 108. That means the acceleration is going to be 4. All right? That is your answer. Great. Now, moving on to question number C, the C part of this, is find a total time for which the car is in motion. That means the whole time for this, okay. So we know the acceleration, we know the velocity now, which is 4. Okay. So first, I think let's find the time for this part. Then we find a time for this part. And then finally we find a time for this part. So for number 1, the first part, we know the acceleration now. Acceleration now is change in velocity by time. So final we know is 4. Oh, wait, sorry. I think I messed it up. This is 20. Sorry, my bad. So acceleration is 4. This is 4. This is minus 8. Right. So 4 is equals to 20 by t. Then that means t is equals to 5 seconds. So over here, this is 5, and this takes 25. That means this is 30. Now what about a deceleration? The deceleration is gonna be... Deceleration is... Right, so we have 20, 0, and then this. Okay, so minus 8 minus 20 by t. So t is going to be 2.5 seconds. That means 30 plus 2.5. That means this is going to be 32.5. So the whole time is going to be 32.5 seconds. Right. So total time 32.5 seconds. Right. Now, question number 3. Question number 3. Okay, this is right into October session. So the diagram shows a velocity diagram. So in this question, the graph is already drawn for us, which is quite great actually. It means we don't have to go through the hassle of drawing the graph, then solving. So the diagram shows a velocity time graph which models the motion of a car. The graph consists of 4 straight line segments. The car accelerates at a constant rate of 2 meters per second square from rest to a speed of 20 meters per second over time t periods. Okay, all right. It then decelerates at a constant rate for 5 seconds before traveling at a constant speed of v meters per second for 27.5 seconds. The car then decelerates to rest at a constant rate over a period of 5 seconds. Okay. Find t. Right. How do you find t? Well, there are many ways you can find t actually. So we know the acceleration, don't we? The car accelerates at a constant rate of 2 meters per second. So over here, the acceleration here is 2. So acceleration, let's change the speed, 20 by t, which means t is actually 10 seconds. That's it, simple as that. Now, given that the distance traveled up to the point at which the car begins to move at constant speed is 1/3 of the total distance traveled, find v. That means that this distance is 1/3 of the whole distance traveled. So we can write that as the equation. We can write first the triangle of this half into base, which is 10 to height 20. So this thing is 1/3 of the whole area. So what's the whole area? Which is this triangle plus this part, which is a trapezium, plus this rectangle plus this triangle. Okay, so what about this trapezium? This trapezium is gonna be, it says that right, then decelerates at a constant speed rate of 5 seconds. So this is 10, this part's 15, and decelerates at a constant rate for 5 seconds before traveling at a constant speed for 27.5 seconds. That means this part, this is 42.5 seconds. This is a constant over a period of 5 seconds. That means this is 47.5 seconds. Okay, that's good. Great. We have now all the information we need. So let me just put this over here. It's going to be pretty long actually. So now, half into one side, which is going to be v. The other side, trapezium, 20. The height is 5. Right. Now for the rectangle, which is gonna be 27.5 v. Let's move this even bad. We're running out of space.